Hello, night travelers. Those gentle, wandering souls seeking tranquility amid the quiet symphony of the night. Welcome back to the Night Observer, a place where hearts come to rest, where comfort and peaceful sleep are found, and where thoughts drift softly toward the vast and mysterious universe. Settle into a comfortable position on your bed. Let your shoulders loosen completely. Feel a quiet warmth spreading from your chest to your fingertips. A small fire is glowing in my mind tonight, and once again we gather around it, letting its warmth hold us as we listen to the slow, graceful dance of planets and stars. If this space brings you calm, please consider liking and subscribing to support our journey together, and to receive a gentle invitation when our next story begins. Tonight, I invite you on one final journey toward a place where even light grows weary, where the human imagination is humbled by the grandeur of emptiness. Welcome to our reflection on the edge of the universe. This is the prelude to a journey without end, the shadow of an unreal wall. In our daily lives, we understand the world through boundaries. A field ends at a fence. An ocean meets a sandy shore. A room is defined by its walls. And so, when we raise our eyes to the velvety black sky scattered with distant lights, a natural question quietly forms within us. Where does the universe end? Is there a wall at the edge of space? In truth, the idea of an edge of the universe is far different from what our instincts suggest. If you imagine flying a spacecraft straight ahead until it collides with a barrier, brick, membrane, or cosmic curtain, the universe offers a gentler, more elusive answer. It may not have edges in that way at all. Take a slow, deep breath and imagine yourself resting at the center of a vast sphere of light. When people speak of the universe's edge, they are usually referring to the boundary of the observable universe, a colossal sphere centered on us, containing everything whose light has had time to reach our eyes during the last 13.8 billion years. From where you are lying now to the edge of that observable realm is about 46.5 billion light years. This creates a bubble of awareness roughly 93 billion light years in diameter. Within it lies all that we can know. The wall at its boundary is not a physical limit of space, but a limit imposed by time and light. When we look into the deep darkness of space, we are not seeing an end. We are seeing light that has been stretched beyond our ability to detect it. Think of light as ripples on a quiet lake. Close to where a stone falls, the waves are clear and distinct. As they travel outward, they weaken until they fade from sight. The edge of the visible universe is not truly black. It is an ancient wall of light, the first glow released when the early universe cooled enough for light to travel freely. We call this the cosmic microwave background, a faint afterimage of creation itself, captured as the universe was only 380,000 years old. For our telescopes today, it is the soft silk curtain marking the limits of what we can see. Here lies a quiet paradox that invites reflection. If the universe is 13.8 billion years old, why is its observable edge 46.5 billion light years away? Shouldn't we see only as far as light has traveled in that time? The answer rests in the subtle dance of cosmic expansion. Imagine light as an ant crawling along a stretching rubber band. As the ant moves forward, the surface beneath it lengthens. In the same way, while light has been traveling toward us for billions of years, the space it moves through has been expanding. Objects that emitted light long ago are now far farther away than they were when that light began its journey. Space is not an empty, static container. It is a living fabric, continuously reshaping itself. Allow your body to soften as you consider this boundless embrace. The cosmic edge is not like the wall of a room. Imagine instead that you are a two-dimensional being living on the surface of a great sphere. You could travel endlessly without ever encountering a boundary, eventually returning to where you began. To you, the surface would feel infinite, even though it is finite. Our universe may be similar, though on a far higher dimension. There is no outside for it to expand into, because the universe is all that exists. What we call the cosmic edge is, in truth, an event horizon. Like the horizon at sea, it marks the limit of our vision, not the end of reality. And here is the most haunting thought of all. Because space is expanding faster and faster under the influence of dark energy, some regions of the universe are now moving away from us more quickly than light itself. This does not violate physics, for it is space, not matter, that expands. Galaxies beyond that horizon will never be seen again. Their light can no longer reach us. We are travelers on a slowly shrinking island of light, surrounded by an infinite ocean of night. The so-called wall at the edge of the universe is only a shadow cast by forgetting. The farther we look into space, the deeper we look into the past. To see Andromeda is to see 2.5 million years ago. To see the cosmic microwave background is to witness the dawn of creation itself. The edge of the universe is not a place, it is a moment. You cannot travel to it by spacecraft, just as you cannot drive your way back to yesterday. It marks the beginning of time, where space and time were born together. Let your thoughts grow light, like drifting cosmic dust. The vastness of the universe is not meant to diminish us, but to remind us of our quiet miracle. We are stardust that has awakened to wonder. Though we live on a small, pale blue world, our minds have reached the very edge of the visible horizon, touching eternity with understanding. Tonight, you are safe, cradled by Earth, sheltered by its atmosphere, wrapped in the stillness of night. Everything moves according to its grand rhythm, and so do you. Let your heart beat slow, aligning itself with the distant music of the stars. Relax completely. Let your eyelids grow heavy. Drift gently into peaceful sleep beneath the shimmering ribbons of the Milky Way. The universe began in a brilliant silence, and now it watches over your rest with boundless calm. The fire in our minds has softened into quiet embers, like stars fading near the horizon, guiding you into the most gentle and beautiful dreams. Welcome to Inside the Bubble of Perception, the Visible Universe. Tonight, we will not speak of nearby planets or solitary stars. Instead, we will drift inward toward the greatest reality humanity has ever faced, the immense cosmic bubble that contains everything we have ever known, observed, and measured since the dawn of time. Take a slow, deep breath. Let your heartbeat align with the eternal rhythm of space and gently listen to the story of the edge of our world. The shadow of an unreal wall. Dear night travelers, in our everyday lives, we understand reality through boundaries. A field ends at a fence, an ocean meets a sandy shore. And so, when we lift our eyes toward the shimmering, velvety black sky, a quiet, instinctive question naturally arises. Where does the universe end? Is there a wall, solid, vast, and final, at the edge of space? In truth, the idea of an edge of the universe is far different from what our instincts imagine. Science suggests that the universe may not possess an edge in the way we understand walls or borders. Imagine for a moment that you are a two-dimensional being living on the surface of a great sphere. You could travel endlessly without ever encountering a boundary, eventually returning to where you began. Our universe may be similar, finite yet without edges, but unfolding on a higher, four-dimensional scale. What we call the edge, then, is not a physical boundary of space itself. It is the boundary of perception. It is the limit of what we can see. This boundary is known as the observable universe, a vast sphere centered on us, containing everything whose light has had enough time to reach Earth over the past 13.8 billion years. Beyond this bubble, space may continue, but its light has simply not yet arrived. Numbers that melt the intuition. Pause for a moment and let these numbers settle gently into your mind. Although the universe is 13.8 billion years old, the radius of the visible universe today is about 46.5 billion light years. This seems impossible at first glance. How can we see farther than the universe has existed? The answer lies in the quiet miracle of cosmic expansion. Imagine light as an ant crawling along a stretched rubber band. While the ant steadily moves forward, the surface beneath it continues to stretch. In the same way, as light travels through space, the space itself expands. As a result, the full realm of human vision now spans a sphere nearly 93 billion light-years in diameter. Some of the most recent measurements, including data from the James Webb Space Telescope, suggest it may be even slightly larger. Within this vast bubble, humanity has uncovered an astonishing treasure: roughly 2 trillion galaxies, more than all the grains of sand on every beach on Earth combined. Each galaxy contains hundreds of billions of stars, woven together into a quiet tapestry of light and time. The childhood image of creation. If you were to ask what lies at the furthest edge of this vision, the answer would not be darkness, but light. The most ancient light of all, the cosmic microwave background, or CMB. About 380,000 years after the Big Bang, the universe was still a dense, glowing fog of charged particles, trapping light in every direction. Then, as the cosmos cooled and atoms finally formed, that fog lifted. For the first time, light was free to travel. That first glow still surrounds us today, stretched and cooled into faint microwaves. The CMB is not merely the edge of our sight. It is the universe's childhood photograph. Within its subtle patterns lie the tiny fluctuations that would one day grow into galaxies, stars, and worlds. Through this ancient light, humanity has reconstructed the story of creation itself, the giants of the cosmic web. Inside this bubble of perception, matter is not scattered randomly. Instead, the universe reveals itself as a vast cosmic web. Galaxies trace immense filaments of invisible dark matter, separated by enormous, silent voids. We have mapped structures of almost unimaginable scale: the Sloan Great Wall, stretching more than 1 billion light-years, and the Hercules Corona Borealis structure, extending nearly 10 billion light-years across. To cross it at the speed of light would require most of the universe's lifetime. Our own Milky Way is not alone. It belongs to the local group, itself a small part of the supercluster Laniakea, a name meaning endless paradise. This colossal structure contains around 100,000 galaxies, all gently flowing toward an unseen gravitational center known as the Great Attractor, the ocean of darkness. Yet, dear night travelers, perhaps the most humbling discovery of all is this: everything we see, the stars, the galaxies, the glowing structures of light, accounts for less than 5% of the universe. The rest is invisible. About 27% is dark matter, the unseen framework holding galaxies together, and 68% is dark energy, a mysterious force driving the universe's accelerated expansion. Because of this expansion, a quiet truth emerges. Our bubble of perception is slowly shrinking. Most of the galaxies we can see today have already crossed a cosmic horizon. Their future light will never reach Earth. We are travelers on a gradually shrinking island of light, adrift in an endless ocean of darkness. The quiet miracle of stardust. As the night deepens, let your thoughts find rest in one final truth. Against the immensity of the visible universe, Earth is only a fragile point of light, a faint blue dot. Yet within that dot exists consciousness. Every atom in your body, iron in your blood, calcium in your bones, was forged in stars that lived and died billions of years ago. We are stardust that has awakened. Though confined within this bubble of perception, humanity has learned to look back through 13 billion years of time, to measure eternity with mathematics, and to feel beauty within vast emptiness. We are the universe becoming aware of itself. Now, allow thoughts of superclusters, ancient light, and dark energy to gently fade into the mist of sleep. Space is your vast home, and Earth is the warm room quietly sheltering you tonight. Everything continues its great rhythm, and so do you. Let your heartbeat soften and harmonize with the distant music of the stars. Night travelers, welcome to our quiet gathering, breaking the paradox of distance. Let your breathing slow and fall into harmony with the flow of space itself, and allow the gentle footsteps of traveling light to lull you toward a peaceful rest. Introduction: Numbers that melt intuition. Dear friends, since the first moment of awareness, humanity has gazed into the night sky and asked a simple yet profound question: where does the universe end? In our daily lives, distance feels manageable. A kilometer is a short walk. The Earth's circumference, 40,000 kilometers, is a number the mind can comfortably hold. But the moment we step beyond our planet, those familiar measures dissolve, becoming as insignificant as grains of sand scattered across an endless desert. To approach infinity, science relies on a single, unwavering constant: the speed of light, traveling nearly 300,000 kilometers every second. From our most precise observations of cosmic expansion and ancient radiation, we have determined the age of the universe to be 13.8 billion years. By ordinary logic, if light is the fastest traveler, and the universe has existed for that span of time, then the furthest distance we should be able to see ought to be 13.8 billion light years. And yet, here begins the paradox that quietly unsettles all intuition. The radius of the observable universe, the great bubble of perception surrounding us, is not 13.8 billion light years, but 46.5 billion. Its full diameter stretches to nearly 93 billion light years. Pause for a moment. Breathe slowly. How can light that has traveled for 13.8 billion years now be located more than 3 times farther away? How can a messenger born near the dawn of time reside at such an immense distance today? The trap of stillness and Einstein's legacy. To resolve this paradox, we must first let go of an ancient illusion, the belief that space itself is fixed and unmoving. Until the early 20th century, even Albert Einstein imagined the universe as a static structure, an eternal stage upon which stars quietly rested. To preserve this stillness, he introduced the cosmological constant into his equations, a delicate balance meant to counter gravity. But the universe refused to remain still. In the 1920s, astronomer Edwin Hubble revealed a truth that reshaped human understanding. Galaxies are not standing in place. They are moving away from us. More than that, the farther a galaxy lies, the faster it recedes. Space itself is not a passive container. It is alive, dynamic, and continuously unfolding. This realization is the first key to the paradox. The universe is expanding, not because galaxies are racing through space like fragments from an explosion, but because space itself is stretching, creating more distance within itself, everywhere at once. Imagine a vast fabric gently pulled in all directions. The dance of the ant on the rubber band. Night travelers, let your mind rest on a familiar image. Picture light as a tiny ant crawling along a long rubber band. You stand at one end, Earth, while the ant begins its journey toward you from the other. If the band were still, the ant would arrive in a predictable time, but now imagine the band slowly stretching as the ant moves. The ant crawls at a steady pace relative to the surface beneath its feet, yet the path itself grows longer. When the ant finally reaches you, The total distance it has crossed is far greater than the band's original length. So it is with light. A photon from the edge of the universe has traveled for 13.8 billion years, but during that time, the space it crossed has expanded. Today, the source of that light lies 46.5 billion light-years away. That distance is not how far the light traveled, but where its source now resides. The paradox dissolves when we accept a simple truth. The universe grows with every passing second. Cosmic inflation, the great leap forward. Still, one question remains. How did the universe grow so vast in such a relatively short time? To answer, we must return to a moment of extraordinary intensity, just 10 to the power of minus 32 seconds after the Big Bang. Scientists call this fleeting era cosmic inflation. In that infinitesimal instant, a region of space smaller than an atomic nucleus expanded to the scale of a galaxy or beyond. This expansion occurred far faster than the speed of light. At first, this seems to contradict Einstein himself. But Einstein's limit applies to matter and information moving through space, not to space expanding on its own. Inflation laid the foundation of the cosmos we inhabit today, smoothing it, flattening it, and stretching it into the vast, velvet-like expanse above us. Without it, the universe would be smaller, more chaotic, and far less serene than the one watching over you tonight. Dark energy, the quiet accelerator. As if that early expansion were not enough, the universe revealed one final surprise. In 1998, observations of distant supernovae showed that cosmic expansion is not slowing down, it is accelerating. Against expectation, galaxies are separating faster and faster. The force behind this acceleration is dark energy, an invisible presence that makes up about 68% of the universe. It fills even the emptiest regions of space, gently pushing everything apart. Because of dark energy, some galaxies are now receding from us faster than light itself. Their future light will never reach Earth again. We live in a rare and precious moment, when the universe still allows us to glimpse its deep past, before the expanding horizon quietly closes. Redshift, time stretched into color. How do we know space is stretching? The answer is written in light itself. As galaxies move away, their light is stretched, shifting from blue toward red. This phenomenon is known as redshift. The farther we look, the redder the light becomes, until it slips beyond visibility altogether and transforms into cold microwaves. This ancient glow is the cosmic microwave background, the universe's earliest surviving image, formed when light first broke free, 380,000 years after the Big Bang. It is the final wall of light, the ultimate boundary of perception. In it, we see confirmation of the vast distances light has endured and the expansion that carried it there. Together, night travelers, we see that what once appeared absurd is in truth a quiet and elegant symphony, where space expands, time stretches, and light faithfully carries memory across the ages. Whether the universe spans 93 billion light-years or extends infinitely beyond, the greatest wonder remains this, that a small being on a pale blue dot can measure eternity at all. You are not separate from the universe. You are the universe, gently learning to understand itself. Now let these thoughts drift away. Space is your vast home, and Earth is the warm room holding you safely tonight. Everything continues in its great rhythm, and so do you. Let your heartbeat soften and merge with the distant harmony of the stars. Relax your body completely. Let your eyelids grow heavy. Drift into peaceful sleep beneath the silken arc of the Milky Way. The universe was born from a brilliant silence, and now it watches over your rest with boundless calm. Night travelers, join me on a journey to a place where even light grows weary, where human imagination is gently tested by the vastness of nothingness. Tonight, we contemplate a quiet and unsettling question. What lies outside, and what does it mean for the universe to be infinite? Let us begin by returning to the familiar shelter of perception, the great cosmic bubble within which humanity resides. In our everyday lives, we understand the world through clear boundaries. Yet when we lift our eyes to the velvety black sky, an ancient question naturally arises. Where does the universe end? Is there a wall at the edge of space? In truth, the so-called edge of the universe is not a physical barrier of stone or light. It is a boundary defined by perception itself. The visible universe is a vast sphere centered on Earth, containing everything whose light has had enough time to reach us during the past 13.8 billion years. Because space itself has been expanding, this bubble now spans nearly 93 billion light-years in diameter, a number so immense it quietly dissolves all familiar intuition. And so we ask, softly, what lies beyond that boundary? Scientists tell us that space does not simply stop where light has yet to arrive. This limit is known as the particle horizon, much like the horizon at sea. It marks the edge of what we can see, not the end of what exists. To glimpse what may lie beyond, we must turn our thoughts back to an extraordinarily violent and brief moment, the inflationary epoch. Just fractions of a second after the Big Bang, around 10 to the power of minus 36 seconds, the universe underwent a sudden and staggering expansion. A region smaller than an atomic nucleus swelled to the size of a galaxy or more in an instant. This expansion occurred far faster than the speed of light, not because matter raced through space, but because space itself came into being everywhere at once. Inflation helps explain why the universe appears smooth, flat, and remarkably uniform in temperature across all directions. Without it, the cosmos would be fragmented and uneven, a far less tranquil place than the one unfolding above you tonight. From this idea emerges an even more astonishing possibility: eternal inflation. Many models suggest that once inflation begins, it never fully stops. Instead, it ends only in localized regions, creating pocket universes like our own, while continuing endlessly elsewhere. In this view, our universe becomes a single bubble drifting within an infinite ocean of other universes. This is the quiet and profound idea known as the multiverse. Here, the Big Bang is no longer a unique event, but one expression of an ongoing creative process. Each cosmic bubble may possess different physical laws. Some collapse instantly. Others never form atoms at all. We exist in this universe simply because its conditions are balanced just well enough to allow stars, planets, life, and thought itself to emerge, an observation known as the anthropic principle. Now, let your thoughts rest gently on the idea of infinity. If space is truly infinite and broadly uniform, then every possibility, however rare, must repeat endlessly. Physicist Max Tegmark describes this as a level 1 multiverse, where far beyond our horizon, at unimaginable distances, there may exist regions of space identical to our own. Somewhere beyond what we can ever see, there could be another version of you, lying quietly beneath another sky, listening to another night, drifting toward sleep. Whether these ideas remain theoretical or someday become established truths, they point to a single humbling realization. We live on a small island of light within an immeasurable ocean of darkness. This vastness is not meant to diminish us, but to illuminate the quiet miracle of awareness itself. Every atom in your body carries the memory of ancient stars, and your consciousness is a single precious note in the endless symphony of space-time. Though we may never reach what lies outside, nor witness parallel worlds, the fact that the human mind can even imagine eternity is itself a profound triumph. Space is a vast home, and Earth is the warm room silently sheltering you tonight. Everything continues to move in its grand rhythm, and so do you. Let your heartbeat soften and align with the distant music of the stars. Relax your body completely. Let your eyelids grow heavy. drift into the most peaceful sleep, surrounded by shimmering galaxies. The javelin argument and the quiet logic of infinity. Night travelers, the idea that the universe may be infinite is not a product of modern science alone. It was first contemplated long ago in the calm and patient reasoning of ancient philosophers. Let us return for a moment to the javelin argument proposed by the Greek thinker Archytas. Archytas asked a deceptively simple question. Imagine you travel to the very edge of the universe and throw a javelin straight ahead. What happens next? If the javelin continues to fly, then space must extend beyond that point. But if it is stopped, there must be something there to stop it, an obstacle of some kind. And if such an obstacle exists, it too must occupy space, implying that there is still something beyond. By this logic, a true final boundary can never be reached. This quiet reasoning became one of the earliest arguments in favor of an infinite universe. Modern science approaches the question differently, guided by Einstein's general theory of relativity. According to this framework, the overall shape of the universe depends on the density of matter and energy within it. Data from the Planck satellite, our most precise measurements to date, suggest that the universe is remarkably flat, with only the smallest margin of uncertainty. In familiar Euclidean geometry, a flat surface naturally extends without end, hinting once again at infinity. Does infinity trouble the human mind? Here, night travelers, we enter deeper waters. Does the idea of an infinite universe conflict with philosophy, with logic, or even with the quiet instincts of the human spirit? For many, infinity awakens a subtle unease, a sense of boundless uncertainty. Physicist Max Tegmark has noted that in an infinite and uniform universe, every possible configuration of matter must repeat endlessly. Somewhere, at an unimaginable distance of roughly 10 to the power of 1,115 meters, there may exist another version of you, lying quietly in another room, listening to words much like these. Philosophy asks a gentle but unsettling question. If there are countless versions of you, what becomes of individuality and meaning? Infinity also sharpens the edge of other paradoxes. Consider the great silence, often called the Fermi paradox. If the universe is infinite and the opportunities for life are endless, why have we not encountered anyone else? Some thinkers, including Peter Ward, suggest that Earth may be an extraordinary exception, a fragile and solitary miracle suspended in a vast, indifferent void. Others take a different view. Followers of the mediocrity principle argue that Earth holds no privileged position at all. In their eyes, life is not a rare accident, but a natural outcome of physics given enough time and space. From this perspective, infinity is not a contradiction. It is abundance, a quiet generosity of creation, ensuring that life will arise somewhere, sometime. What lies outside and the multiverse? If the observable universe is merely a small bubble floating within a greater expanse, then what lies beyond its edge? Inflation theory offers a compelling possibility. The most widely discussed idea is eternal inflation. According to this view, inflation does not end everywhere at once. Instead, it continues endlessly in the larger fabric of space, constantly giving birth to new bubble universes. Each bubble may possess its own physical laws and constants. This is the calm and astonishing idea known as the multiverse. Within this framework, the Big Bang is no longer a singular, unique event, but one of countless beginnings unfolding across a far greater reality. We exist here simply because this particular universe happens to have conditions that allow stars, chemistry, life, and thought to emerge. A quiet truth summarized by the anthropic principle. The night is deep now. Let your thoughts rest gently. Whether the universe is infinite or a vast, delicately curved whole, whether we dwell on a solitary, faint blue dot or among countless unseen worlds, The fact that a thinking species can measure eternity is, in itself, a profound miracle. Our journey to the edge of all things ends here. You have seen that the boundaries of space are, in essence, boundaries of time and light. You are not an outsider looking in. You are the universe, slowly becoming aware of itself through thought and feeling. The atoms within your body once burned in ancient stars, and tonight you remain a single, irreplaceable note in an endless cosmic symphony. Everything continues to move in its grand rhythm, and so do you. Let your heartbeat soften and fall into harmony with the distant music of the stars. Relax your body completely. Let your eyelids grow heavy. Drift into the most peaceful sleep beneath the silken ribbons of the Milky Way. The universe began in brilliant silence, and now it quietly watches over your rest with boundless compassion. When you gaze into the depths of space, you are never truly seeing the universe as it exists now. Instead, you are gently drifting through ancient layers of time. Light, our only faithful messenger, travels at an absolute yet finite speed of nearly 300,000 kilometers per second. Because of this delay, every telescope becomes a quiet time machine. The image of the moon you see belongs to 1.3 seconds ago. The warmth of sunlight on your skin began its journey more than 8 minutes in the past, and the faint glow of the Andromeda galaxy set out 2.5 million years ago, at a time when our earliest human ancestors were only beginning to walk the grasslands of Earth. The farther we look into space, the deeper we peer into history, drawing ever closer to the Big Bang, the moment when space and time themselves first took shape. Yet here, night travelers, intuition begins to falter. If the universe is only 13.8 billion years old, why does the visible boundary lie 46.5 billion light-years away? The answer rests in the quiet miracle of cosmic expansion. Imagine light as an ant crawling along a stretched rubber band. As the ant steadily moves toward you, the band beneath its feet continues to lengthen. In the same way, while light has been traveling for 13.8 billion years, the space it crosses has been expanding all the while. Objects that emitted their light at the dawn of time are now far farther away than their light's travel time would suggest. The universe is not a rigid container. It is a living fabric, continuously reshaped under the subtle pressure of dark energy. At the very edge of our awareness, where stars and galaxies slowly fade from view, we do not meet absolute darkness. Instead, we encounter an ancient glow, the cosmic microwave background. This is the universe's childhood photograph, captured 380,000 years after the Big Bang. Before that moment, the cosmos was a dense, seething fog of charged particles, where light was trapped and unable to roam freely. As the universe cooled and atoms formed, the fog lifted, and light began its long, silent journey. That first light still surrounds us today, forming the final wall of visibility, a delicate veil of time marking the boundary of what we can ever see. But what lies beyond that vast 93 billion light-year bubble? Scientists tell us that space does not simply end where light has not yet arrived. This boundary is merely an event horizon, much like the horizon at sea, a limit of vision, not the end of the ocean itself. Inflation theory suggests that in its earliest moments, the universe expanded at a rate far exceeding the speed of light, stretching a tiny seed into an unimaginable expanse. If this is true, the universe beyond our sight may be trillions of times larger than what we observe, or perhaps infinite. In such an infinite and uniform cosmos, physics and philosophy begin to intertwine. Physicist Max Tegmark has proposed that if one travels far enough, on the order of 10 to the power of 1,115 meters, regions of space may repeat themselves exactly. Somewhere beyond the horizon, there may be another version of you, lying quietly in another room, listening to these same words and preparing for sleep. The The multiverse hypothesis extends this vision even further, suggesting that our universe may be just one small bubble in an endless sea of others, each governed by different physical laws. We exist here simply because this universe happens to offer conditions that allow life to emerge. Whether the universe is infinite or finite, one truth becomes clear. Our sense of being central gives way to a deeper humility. We live on a tiny pale blue dot, circling an ordinary star on the outskirts of a modest galaxy. Yet this physical smallness is precisely what reveals the grandeur of consciousness. Every atom in your body, the iron in your blood, the calcium in your bones, was forged in the hearts of stars that burned and died billions of years ago. We are stardust that has awakened, the universe learning to observe and understand itself through thought and awareness. When you look into the universe's past through the window of light, you are also searching for your own beginnings. And still, the universe quietly hides the present and the future from us. Driven by dark energy, distant galaxies are retreating faster than light itself. The boundaries of the observable universe are slowly closing. More than 96% of the galaxies we see today have already crossed the event horizon, their light destined never to reach Earth again. We are travelers on a shrinking island of light, surrounded by an ocean of eternal darkness. Far in the future, the night sky will grow completely black, and those who live then may believe they are utterly alone, unaware that a vast cosmos once revealed itself in brilliance. As we contemplate ultimate endings, the cold stillness of a big freeze, or the tearing apart of a big rip, philosophy gently reminds us to rest in the present. The universe may one day fall into a timeless sleep, but it will do so carrying every story it has ever written. Whether we are alone or not matters less than this, that we dared to look up, to wonder, and to ask the deepest questions. We are a small speck of stardust learning to dream, a brief sentence on the opening page of a vast cosmic book still being written. Night travelers, our journey into the depths of awareness ends here. You have seen that the boundaries of space are, at their heart, limits of time and light. And you have felt that though we are small, we are forever woven into this great and silent symphony. Now, let your thoughts settle. Let the universe continue its slow rhythm, and allow yourself to drift gently into rest beneath its quiet watch. Are you still here with us, night travelers? If so, let us turn our full attention to First Gazes into the Void. This chapter carries us back to the dawn of human awareness, to the distant dreams of a time when our ancestors first lifted their eyes to the night sky and quietly asked, "Are we alone?" Allow your thoughts to drift along the silken ribbons of time and listen closely to the whispers left behind by the past. Myths weave the star carpet. From the earliest days of humanity, long before electric lights dimmed the heavens, our ancestors stood beneath a sky ablaze with stars. They watched the Milky Way flow overhead like an eternal river of milk. Without James Webb or Hubble to guide them, they relied instead on imagination, rich, vivid, and deeply human, to make sense of what they saw. To them, the universe was not a place of black holes or dark matter, but a grand stage inhabited by gods and mythical beings. In the 7th century BCE, Babylonian astrologers imagined the world as a flat disk encircled by ocean, sealed beneath a fixed celestial dome. In the epic Enuma Elish, they believed the Milky Way was formed from the severed tail of the primordial dragon Tiamat, cast across the sky after her defeat by the god Marduk. Each point of light was not a distant sun, but a sacred sign, inscribing the fate of humankind upon the heavens. Far to the west, the ancient Greeks told the story of Heracles. They believed the Milky Way, Galaxias Kyklos, the circle of milk, was born when the goddess Hera pushed the infant Heracles from her breast, scattering divine milk across the sky. From this very word, galactos, our modern term galaxy would one day emerge. Across the ocean in Central America, the Maya regarded Venus with reverence, calling it No-Ek, the great star. They built their religious calendar around its movements, calculating its orbit with astonishing precision, accurate to within 1/100th of a day. Different cultures, different stories, yet all shared a single conviction. Earth stood at the center, unique and irreplaceable. Arthur C. Clarke once observed that either we are alone in the universe or we are not, and that both possibilities are equally terrifying. For the ancients, being at the center offered comfort, a reassuring, if illusory, sense of importance. The seeds of rational thought. Slowly, night travelers, myth began to loosen its grip as reason stirred. Greek philosophers dared to imagine a universe governed not by capricious gods, but by natural laws. They turned away from tales of Apollo's chariot pulling the sun across the sky and began to seek explanations rooted in observation and logic. In the 5th century BCE, Anaximander proposed that all things arose from a pyrrhon, an infinite, boundless substance from which everything is born and to which it will return. Anaxagoras went further still, declaring that the sun was not a god, but a vast, blazing mass, larger than the Peloponnesus itself, a claim that earned him the label of heretic. Perhaps the most remarkable vision came from Democritus and Epicurus. Long before telescopes, they imagined a universe filled with countless worlds. Epicurus reasoned that if atoms are infinite and their laws universal, then the processes that shaped life on Earth must occur elsewhere as well. These were the first faint sparks of what we now call astrobiology. In India, ancient Jain texts spoke of multiple realms beyond the visible world, lands such as Bharat Kshetra and Mahavidya Kshetra, where life could also arise. The universe, in their view, was not a closed box, but an open expanse of cycles, rebirth, and parallel existence. Aristotle's wall and Ptolemy's paradox. Yet these early visions were soon enclosed by a formidable wall of thought. Aristotle's geocentric universe would dominate human understanding for nearly 15 centuries. In his orderly cosmos, Earth rested motionless at the center, surrounded by transparent crystalline spheres carrying the moon, the planets, and the stars. Earthly matter followed one set of rules. Heavenly matter, made of ether, followed another entirely. Aristotle denied even the existence of a vacuum, insisting that nature could not tolerate emptiness. By the 2nd century CE, Claudius Ptolemy refined this worldview in Alexandria. In his Almagest, he introduced epicycles and equants to explain the wandering motions of the planets while preserving Earth's central role. Though fundamentally flawed, the model worked, accurately predicting celestial movements and earning unchallenged authority within the church and medieval scholarship. For 15 centuries, humanity slept within this crystal cage, believing itself the focus of creation, while the stars beyond waited patiently for a clearer vision. Light from the east and quiet descent. While much of Europe lay in intellectual shadow, the flame of astronomy burned steadily in the Islamic world. In the 11th century, Ibn al-Haytham redefined space using rigorous geometry, quietly dismantling Aristotle's assumptions. Al-Biruni suggested that the Milky Way was composed of countless faint stars, and later, Nasir al-Din al-Tusi described it as an immense cluster so dense it appeared cloud-like. Thinkers such as Fakhr al-Din al-Razi even drew upon religious texts to argue that creation need not be limited to a single world. With careful observation and growing precision, these scholars laid the groundwork for the eventual collapse of the Earth-centered cosmos. By the 15th century, Nicholas of Cusa dared to suggest that the universe had no true center and no fixed boundary. He called Earth a brilliant star, among others, and proposed that many celestial bodies might be habitable. These ideas arrived like the first warm winds before a long-awaited spring, the shattering of the crystal spheres. The true turning point came in the 16th century with Nicholas Copernicus. By placing the sun at the center and demoting Earth to just another planet, he redrew humanity's map of existence. Yet it was Galileo Galilei who first stepped into this new universe with a telescope in 1609. He saw mountains and craters on the moon, moons circling Jupiter, and a Milky Way composed of countless stars invisible to the naked eye. The crystal spheres shattered under his gaze. Inspired by this new vision, Giordano Bruno declared that every star is a sun, each with its own worlds, perhaps filled with life. Though his ideas cost him his life, Bruno left behind a lasting principle. Earth is not unique, and life is not confined to a single place. You have witnessed how naked-eye observation, myth, and philosophy slowly unfolded into a science devoted to life in the universe. We have journeyed from believing ourselves the center of all creation to recognizing our place on a solitary, pale blue dot. Yet that smallness does not diminish us. It reveals the quiet power of consciousness. We are awakened stardust. Every carbon atom in your breath tonight was forged in a star that died billions of years ago, and every glance you lift to the sky echoes the gazes of ancestors long gone. Night travelers, let us drift gently backward through time to a pivotal moment when humanity first truly opened its eyes to the cosmic void through a quiet yet miraculous invention, the lens. Settle deeper into your bed. Allow every muscle to loosen. Let your breathing slow and float like faint dust clouds suspended between distant galaxies as we begin this chapter. The lens revolution, when Galileo opened the sky. The world in a crystal cage. Before the lens ever touched human hands, dear night travelers, humanity lived for thousands of years within a world both orderly and confined. For nearly 15 centuries, the night sky was not an endless ocean, but a perfect crystal cage. Our ancestors gazed at the winding Milky Way and believed it to be an eternal river of milk, divine, distant, and forever beyond reach. This vision was shaped by the immense authority of Aristotle. He described a geocentric universe where Earth rested motionless at the center of all things, encased within transparent crystalline spheres that carried the moon, the planets, and the stars in flawless motion. In this carefully arranged cosmos, Earth was not merely central, it was singular and supreme. The heavens were composed of ether, a smooth, divine substance, unchanging and perfect, utterly unlike the coarse stones and dust beneath our feet. Though thinkers such as Democritus and Epicurus once imagined countless worlds scattered through a vast universe, their daring ideas were muted by the power of medieval scholarship and religious authority. With unaided eyes, humanity saw only distant points of light, shimmering but indistinct. And so, for centuries, people believed themselves to occupy the most privileged position in creation, until a quiet crack appeared in that flawless crystal shell. The flame, born from glass. This revolution, so profound in its consequences, did not begin in a grand observatory or royal court. It was born instead in modest glass-making workshops in the Netherlands. At the dawn of the 17th century, the first telescope was not crafted by philosophers, but by skilled lens makers who happened upon a curious combination of convex and concave glass. At first, this simple instrument served practical purposes, allowing merchants to spot distant ships approaching the harbor. But when news of this device reached Italy in 1609, it captured the attention of a man whose curiosity knew no limits: Galileo Galilei. Galileo was not the first to construct a telescope, but he was the first to raise it toward the heavens with a questioning scientific mind. Night after night, he refined the lenses, pushing their magnifying power ever further. This was no mere tool. It was a doorway, a narrow window, opening onto eternity. The moon and the moons of Jupiter. One quiet autumn night in 1609, Galileo turned his telescope toward the moon, and in that moment, Aristotle's perfect heavens quietly fell apart. Instead of a smooth, flawless sphere, he saw shadows, ridges, and scars. The moon was rough and uneven, marked by craters and valleys much like those of Earth itself. The shock was profound. The heavens, long believed to be pure and immutable, were suddenly familiar and imperfect. Yet this revelation was only the beginning. When Galileo aimed his telescope at Jupiter, he noticed 4 faint points of light nearby. Night after night, he watched them move. They were not distant stars, but moons, satellites orbiting Jupiter itself. Here was undeniable proof that not everything revolved around Earth. The cosmic hierarchy had been quietly overturned. Then Galileo turned his gaze to the Milky Way. What had once appeared as a pale, misty band dissolved into countless individual stars, far too numerous for the naked eye to perceive. The universe expanded, almost overnight, from a small, orderly structure into a vast and humbling expanse. Venus and the end of the old world. If Jupiter's moons dealt a serious blow to the geocentric model, Venus delivered the final, decisive strike. Through his telescope, Galileo observed that Venus passed through phases, crescent, half, and full, just like our moon. According to Ptolemy's Earth-centered system, such phases should be impossible. Venus could only appear this way if it orbited the Sun. The implication was unavoidable. Copernicus had been right. Earth was not the center. It was merely one planet among others, circling an ordinary star. Galileo went even further, discovering dark spots moving across the surface of the Sun itself. These sunspots revealed that even the great source of light and life was not perfect or unchanging. The ancient ideal of celestial perfection quietly faded into history. The cost of clear vision. Night travelers, truth rarely comes without consequence. Galileo's discoveries placed him in direct conflict with powerful institutions, unwilling to surrender long-held beliefs. His work was deemed dangerous, even heretical, for it challenged both tradition and authority. In 1633, Galileo stood before the Roman Inquisition. He was forced to publicly renounce his support of the heliocentric system and spent the remainder of his life confined to his home. His contemporary, Giordano Bruno, paid an even greater price, executed for proclaiming that every star was a sun, surrounded by worlds alive with possibility. Yet the flame Galileo ignited could not be extinguished. His observations planted the seeds of the mediocrity principle, that Earth holds no privileged position in the cosmos, and that life here is not uniquely sacred or singular. It was a lesson in humility and in belonging. We are not the center of the universe, but participants within it. The legacy of the lens. The telescope revolution of 1609 marked a turning point in human thought. Knowledge was no longer built solely on philosophy or belief, but grounded in observation. From Galileo's fragile lenses emerged a lineage of ever more powerful instruments. Hubble lifted humanity into a golden age of astronomy, revealing galaxies at the edge of visibility and helping us measure the universe's age at 13.8 billion years. And now, the James Webb Space Telescope peers through cosmic dust, gazing back toward the first galaxies born in the earliest moments of time. The journey from Galileo to today is a testament to human curiosity, restless, patient, and enduring. We continue to send our quiet messengers into the darkness, searching for our cosmic neighbors, wondering whether on some distant world, someone else is also looking up tonight and asking the same timeless question. Are you still awake, night travelers? If you are already asleep, that is a blessing. And if you are still listening, then this is a gentle journey, one that traces how humanity has persistently gazed into the darkness in search of the edge of reality. From the quiet devotion of a musician who loved the stars to the great steel and silicon time machines now drifting far above our world. Welcome to the chapter. Measuring Eternity, from Herschel to the Abyss of Hubble. Let your body sink deeper into the comfort of your bed. Release the weight from your shoulders, your arms, your legs. Feel a soft warmth spreading, steady and reassuring. Tonight, we tell the story of the modern eyes that forever changed how humanity understands its place within eternity. Prelude, When the Sky Was a Silent Mystery. Dear night travelers, for most of human history, we defined reality by clear and familiar boundaries. A field ending at a fence, an ocean stopping at a shore. When our ancestors looked up at the shimmering, velvety black sky, they believed it to be fixed and eternal. A silent dome of stars with Earth resting calmly at its center. Measured in kilometers, the world beneath our feet once felt vast. Yet against the scale of the cosmos, such measurements quickly dissolve into insignificance. To approach infinity, humanity was forced to rely on a single, unchanging ruler, the speed of light. But before we could grasp what a light year truly meant, we first had to understand the true nature of the cosmic home we inhabit. William Herschel, the musician who counted the stars. The story of modern cosmology begins not with a formally trained scientist, but with a German-born musician who settled in England, William Herschel. He possessed an unusual passion for telescopes, crafting and polishing mirrors, with a precision unmatched in his time. In the late 18th century, when most believed stars were scattered randomly across a rigid celestial dome, Herschel, working closely with his sister Caroline, undertook an extraordinary task. He decided to count the stars. Dividing the sky into narrow sections, he carefully recorded how many stars appeared in each direction. From this patient effort, a revelation emerged. The stars were not evenly spread. They were densely concentrated along a glowing band, the Milky Way. Herschel drew the first map of what he believed to be the entire universe, a flattened, disc-like structure with the sun near its center. Though we now know his conclusions were limited by unseen interstellar dust, Herschel's legacy endures. He showed for the first time that the universe has structure, that we live inside a vast system rather than beneath a decorative ceiling. Friedrich Bessel and the first ruler reaching the stars. Breathe slowly now, evenly. Imagine the year is 1838. A profound barrier of perception was quietly broken by the German astronomer Friedrich Bessel. Until then, humanity sensed that the stars were distant, yet had no reliable way to measure how far away they truly were. Bessel turned to a subtle technique known as parallax, observing the tiny shift in the position of the star 61 Cygni as Earth moved to opposite sides of its orbit around the Sun. The result was astonishing. The star lay roughly 10 light-years away. For the first time, the concept of a light year entered human understanding, not as an abstraction, but as a measurable distance. The kilometer had become meaningless at this scale. Light itself, racing at its absolute speed, would need more than 10 years to cross that gulf. The door beyond the solar system had opened, revealing a universe vast, silent, and breathtakingly empty. The great debate. Is the Milky Way everything? As the 20th century approached, night travelers, humanity once again faced a crisis of perspective. Astronomers observed faint, spiral-shaped smudges in the sky, objects known as nebulae. In 1920, this uncertainty crystallized into what became known as the Great Debate between Harlow Shapley and Heber Curtis. Shapley argued that the Milky Way was the entire universe, enormous in size, with the nebulae merely small clouds within it. Curtis, however, proposed a far more unsettling idea, that these nebulae were island universes, entire galaxies, millions of light-years away. This debate was not merely technical. It questioned the very limits of reality. Were we inhabitants of a single cosmic fortress, or residents of a tiny island adrift in an immeasurable sea? The answer awaited discovery atop Mount Wilson in California. Edwin Hubble, shattering the final horizon. In 1923, Edwin Hubble turned the 100-inch Hooker telescope, the most powerful instrument of its era, toward the Andromeda Nebula. There, he identified a rare and invaluable type of star, a Cepheid variable. These stars pulse with a predictable rhythm, allowing astronomers to determine their true brightness, and therefore their distance. Hubble's calculations revealed a stunning truth. Andromeda lay far beyond the boundaries of the Milky Way. In an instant, the universe expanded beyond all previous imagination. The Milky Way was no longer everything. It was merely one galaxy among countless others. Hubble continued. Using spectroscopic data gathered by Vesto Slipher, he noticed that galaxies were receding from us. Their light was stretched toward the red end of the spectrum, much like the lowered pitch of a passing siren. The farther the galaxy, the faster it moved away. This relationship, now known as Hubble's law, revealed that the universe itself is expanding. And expansion implies a beginning, a luminous origin we now call the Big Bang, nearly 13.8 billion years ago. Why humanity must place its eyes in space. Dear night travelers, feel the quiet around you now. Have you ever wondered why we send telescopes into orbit at such great cost? Even the most powerful ground-based observatories must peer through Earth's atmosphere, a restless, turbulent veil that blurs starlight and blocks vital wavelengths. Ultraviolet and infrared light, carriers of the universe's deepest secrets, are largely absorbed before they ever reach the ground. To truly measure eternity, humanity had to rise beyond its atmospheric cradle. Modern firekeepers, seeing what eyes alone cannot. Kepler searched patiently for distant worlds, revealing that planets are not rare miracles, but common companions of stars. WMAP and Planck gazed backward in time, capturing the faint afterglow of creation, the cosmic microwave background, allowing us to measure the age and composition of the universe itself. Gaia maps our Milky Way in exquisite 3 dimensions, tracing the movements of more than 1 billion stars with quiet precision. And James Webb, those golden eyes, now peers through ancient dust to witness the birth of the first stars, challenging our assumptions and deepening the mystery. The abyss of perception and great humility. Night travelers. When we raise these instruments to measure the universe, we are met with a quietly astonishing truth. The visible universe forms a sphere roughly 93 billion light-years across. Though the cosmos itself is only 13.8 billion years old, the relentless expansion of space has carried its boundaries far beyond the distance light alone could traverse. We live within an invisible bubble of information, where, with every passing second, tens of thousands of stars slip beyond our reach forever, carried away by the accelerating pull of dark energy. Standing before such an abyss, it is natural to feel small. Yet remember this: physical smallness is not insignificance. It is evidence of the grandeur of consciousness. We, beings formed from the ashes of ancient stars, are the means by which the universe comes to know itself, to reflect upon itself, and perhaps, in its own quiet way, to love itself through awareness. Let your body sink deeper into the comfort of the bed. Allow your shoulders to soften completely, and feel a gentle warmth spreading from your chest to your fingertips. Night travelers. Together, we now turn to the story of a legend that forever reshaped humanity's sense of eternity. Welcome to the chapter, The Hubble Telescope, a window into the dawn of creation. Let your breath drift as softly as the dust clouds between galaxies as we begin the epic tale of the telescope that lifted human vision above Earth's lingering fog. The dream of escaping the fog. Dear night travelers, our story does not begin in 1990, when Hubble finally soared into space. It begins much earlier, with a dream as old as astronomy itself. For thousands of years, those who studied the heavens have wrestled with a silent adversary, Earth's atmosphere. While this atmosphere is a protective shield for life, for astronomers, it is an imperfect window. Air bends and distorts incoming light, making stars appear to twinkle, a phenomenon scientists call seeing, and blurring even the finest details of the cosmos. In 1946, long before NASA existed, astronomer Lyman Spitzer penned a visionary paper titled "The Astronomical Advantage of an Extraterrestrial Observatory." He imagined a telescope suspended in the vacuum of space, free to collect ultraviolet and infrared light absorbed by the atmosphere, revealing the universe with unprecedented clarity. Transforming that dream into reality would prove arduous. One of its most determined champions was Nancy Grace Roman, later known as the mother of the Hubble telescope. Throughout the 1970s, she tirelessly lobbied the U.S. Congress to sustain funding, convinced that this instrument would open an entirely new chapter in human understanding. After decades marked by delays, budget cuts, and the devastating Challenger disaster in 1986, hope finally ignited. On April 24, 1990, the Space Shuttle Discovery carried Hubble into orbit, releasing it into the darkness and into history, the pain of perfection's mistakes. But the universe, it seems, often tests perseverance in the harshest ways. Within weeks of Hubble's first images reaching Earth, optimism turned to disbelief. The pictures lacked the expected sharpness, cloaked instead in a soft, troubling haze. The cause was soon uncovered: a devastating flaw in Hubble's primary mirror. Though it was the most precisely crafted mirror humanity had ever made, it suffered from spherical aberration. Its edge was ground too flat, by a mere 2,200 nanometers, less than 1/50th the thickness of a human hair. The error traced back to a testing device assembled incorrectly by just 1.3 millimeters. Confident in their instruments, engineers dismissed warning signs from other tests. A billion-dollar marvel was suddenly the subject of public ridicule, likened in late-night comedy to the Titanic or the Hindenburg. For many, the dream of deep space observation seemed shattered. Glasses for the giant. Yet in that moment of despair, humanity's most enduring strength revealed itself: the ability to admit error and to repair it. Hubble had been designed from the beginning to be serviced in orbit. In December 1993, the extraordinarily complex STS-61 mission launched. Over 5 demanding spacewalks, astronauts installed COSTAR, a sophisticated system of corrective optics, essentially a pair of precision glasses, for the telescope. On January 13, 1994, the first post-repair images arrived from the galaxy M100. The world paused, almost collectively, to breathe. The images were breathtakingly sharp. Doubt dissolved, and Hubble entered its golden age. With its vision restored, it began to rewrite our understanding of the universe. Hubble, the great time machine. Breathe slowly now, gently, like the patient footsteps of photons that have traveled for billions of years to reach Hubble tonight. Hubble is not merely a telescope, it is a true time machine. Because light moves at a finite speed, when Hubble observes a galaxy 10 billion light-years away, it is witnessing that galaxy as it existed 10 billion years ago, long before Earth was fully formed. Among its most remarkable achievements are the deep field images. Astronomers dared to point Hubble toward a region of sky that appeared utterly empty, letting it stare into darkness for days. The result was astonishing. Thousands of galaxies emerged from that apparent nothingness, each containing hundreds of billions of stars. The universe revealed itself to be far richer, far more crowded than imagination had ever allowed. Hubble also helped refine the age of the universe to 13.8 billion years. Before its observations, estimates wavered uncertainly between 10 and 20 billion. It further confirmed a profound truth. The expansion of space is accelerating, driven by a mysterious force we now call dark energy. Without Hubble, we might still believe the cosmos to be calm and unchanging. Islands of light and brilliant ghosts. Through Hubble's gaze, we learned that nearly every galaxy harbors a titan at its core, a supermassive black hole. Hubble provided compelling evidence of their existence, revealing that these objects are not merely cosmic destroyers, but stabilizing anchors shaping entire galaxies. Closer to home, Hubble has served as a vigilant guardian of our solar system. It witnessed the dramatic collision of Comet Shoemaker-Levy 9 with Jupiter, discovered new moons orbiting Pluto, and mapped icy worlds at the distant frontier beyond Neptune. Each Hubble image is more than data. It is a quiet work of art. The pillars of creation in the Eagle Nebula stand as a symbol of cosmic grandeur, towering clouds of gas and dust where new stars are born. Hubble has fundamentally altered humanity's self-perception. We now understand that we live on a fragile, faint blue dot, adrift in an ocean of trillions of galaxies. This physical smallness does not diminish us. On the contrary, it illuminates the extraordinary power of awareness. We, creatures of stardust, have learned to gaze all the way to the edge of the visible universe, and in doing so, to contemplate our own beginnings. Night travelers, welcome to the chapter James Webb and Modern Infrared Eyes. This is not merely the story of a machine forged from steel and gold. It is an epic continuation, a quiet inheritance of the legacy left by the Hubble Space Telescope, carrying human curiosity into regions of space we once dared to imagine only in our most distant dreams. Take a slow, steady breath. Let your heartbeat fall into harmony with the timeless silence beyond the stars. Tonight, we listen to the story of the eyes that can look through darkness itself into the very dawn of creation. Introduction: When Visible Light Grows Weary. Dear night travelers, for thousands of years humanity understood the universe through the limits of the naked eye, faint points of light scattered across a velvety black sky. When the Hubble Space Telescope was launched in 1990, it opened a golden age of discovery. Galaxies billions of light years away came into focus, sharp and luminous. Hubble taught us that the universe is approximately 13.8 billion years old, and that it is not standing still, but expanding ever faster with time. Yet Hubble sees primarily invisible light, the narrow range our eyes were designed to perceive. And the universe, it seems, has learned to hide its oldest secrets beyond that narrow window. There are two great barriers that visible light cannot cross. The first is cosmic dust. Vast clouds of microscopic particles drift between stars, forming thick veils that absorb and scatter visible light. Within them lie stellar nurseries and galactic cores, concealed from ordinary sight. The second barrier is redshift. As the universe expands, the light emitted by the earliest stars and galaxies is stretched across billions of years. Energetic, visible wavelengths are pulled into longer, gentler infrared waves by the time they reach us. To witness the cosmic dawn, we did not need a larger mirror alone. We needed an entirely new kind of vision. A great succession, from Hubble to James Webb. In December 2021, human vision took a historic step forward. The James Webb Space Telescope rose from Earth, not as a replacement for Hubble, but as its rightful successor, designed to extend its reach and deepen its legacy. If Hubble was a mirror into the distant past, Webb is a true time traveler. Roughly the size of a tennis court, Webb carries a vast primary mirror, 6.5 meters wide, assembled from 18 hexagonal segments of ultralight beryllium, each coated in a thin layer of gold. This gold is not ornamental. It is nature's finest reflector of infrared light. Unlike Hubble, which orbits close to Earth, Webb journeyed alone to Lagrange point L2, nearly 1.5 million kilometers away. There, Shielded from the warmth of Earth and Moon by a massive 5-layer sunshade, its instruments rest in near-perfect cold, only a few degrees above absolute zero. Only in such profound darkness can Webb sense the faint heat of the most distant galaxies, seeing through the mists of the cosmic dawn. One of Webb's greatest achievements builds directly upon Hubble's legacy. Hubble's deep field images revealed galaxy GN-Z11, formed about 400 million years after the Big Bang, an extraordinary reach for visible light, yet also its limit. With infrared vision, Webb went further. It identified the galaxy JADES GSZ140, existing just 280 million years after the Big Bang. These early galaxies were expected to be dim and chaotic. Instead, Webb revealed them to be bright, massive, and growing with surprising speed. Even more puzzling were the discoveries known as little red dots, compact objects harboring supermassive black holes, growing at rates that strain current theories of physics. These findings are compelling scientists to reconsider long-held assumptions, even reopening the question of whether the universe could be older than 13.8 billion years, perhaps approaching 26.7 billion. James Webb is not simply extending Hubble's map, it is revising the opening chapters of cosmic history, the search for life in infrared light. James Webb does more than peer into the distant past. It also carries forward the search begun by Kepler and Tess, the search for possible neighbors within our own galaxy. With extraordinary spectroscopic precision, Webb can analyze the faint starlight passing through an exoplanet's atmosphere, revealing its chemical makeup. In 2023, it turned its gaze toward K218b, a super-Earth 124 light-years away. Webb detected methane and carbon dioxide, hinting at a vast ocean of liquid water, a so-called Hycean world. Most intriguing was the faint signal of dimethyl sulfide, a molecule that on Earth is produced almost exclusively by living organisms, particularly marine plankton. Scientists remain cautious, requiring confirmation at the stringent 5 sigma level. Yet this marked the first time humanity encountered such a strong chemical whisper of life beyond Earth. What Charles Darwin once imagined as a warm little pond has now become a serious interstellar inquiry. The Pillars, reborn. Night travelers, you may remember the iconic Pillars of Creation image captured by Hubble in 1995. Towering columns of dust where stars are born. When James Webb turned its infrared gaze toward the same region, the veil of dust seemed to dissolve. Hidden stars emerged by the thousands, sparkling like scattered diamonds against the black velvet of space. This is the true meaning of inheritance. Hubble revealed the universe's grand outlines. Webb exposes its inner workings. Art became anatomy. Wonder became understanding. We do not look only backward at what humanity has achieved. We also turn our gaze toward the unseen horizon, seeking to understand why we continue to search beyond the limits of sight. Dear night travelers, take one more slow breath. Imagine yourself at the center of an immense sphere of light. For centuries, humans defined the world by solid edges and visible borders. Modern science has shown us something more subtle. The edge we observe is not a wall in space, but a boundary shaped by time and light. We call it the observable universe, a vast sphere containing everything whose light has had time to reach us over 13.8 billion years. Because space itself expands, this sphere now spans roughly 93 billion light-years in diameter. Within it, we have mapped nearly 2 trillion galaxies, each filled with hundreds of billions of stars, woven together along invisible filaments of dark matter. We have Hubble, the great timekeeper that revealed the universe's age and its accelerating expansion under dark energy. And now we have James Webb, with golden infrared eyes that pierce dust and distance alike, reaching the cosmic dawn itself. The ancient galaxies and mysterious little red dots it has uncovered remind us that the universe still holds surprises, and that the story of creation is far from finished. Breathe evenly, slowly. In the quiet of the night, a question always returns, gentle yet persistent. Why do humans believe there is something beyond the visible universe? The first answer lies in the nature of light itself. Light does not travel instantly. It moves at a finite speed. What we call the edge of the visible universe is merely a particle horizon, the point from which light has not yet had time to reach us. It is like standing by the sea at night. Your eyes meet the horizon, yet you know the ocean does not end where your vision stops. There is no physical reason to believe that space simply vanishes beyond the reach of light. The second answer comes from inflation theory. Scientists propose that in the first fleeting moment after creation, the universe expanded at an extraordinary rate, faster than light itself, stretching a minute seed into an unimaginably vast expanse. If this is true, then everything we can observe today is no more than a single grain of sand on an endless cosmic shore. The third clue lies in the remarkable uniformity of the cosmic microwave background. This ancient afterglow tells us that regions of space now separated by billions of light years were once intimately close, parts of a much larger whole. And finally, there are the mathematical visions of the multiverse, models suggesting that our universe may be just one delicate bubble in an infinite sea, each bubble shaped by its own set of physical laws. Have you ever wondered why we devote ourselves to searching for something that may forever remain beyond our reach? The first reason is survival. Earth is a radiant yet fragile jewel. We know that in the distant future, the sun will grow hotter and the oceans will eventually vanish. The search for nearby worlds, places like Proxima Centauri b or distant Hycean planets, is humanity's quiet preparation for a far-off migration, a way to ensure that the flame of consciousness does not fade when our ancient home can no longer shelter life. The second reason is identity. The question, "Are we alone?" is, at its heart, the question, "Who are we?" To discover even the simplest microorganism on Mars or beneath the icy oceans of Enceladus would tell us that life is not an accident, but a universal tendency. Such a discovery would forever change our role in the great symphony of creation. And then there is the final reason, the most profound and perhaps the most poetic of all. We are the way the universe comes to know itself. We are stardust that has awakened, carrying within us atoms forged in the hearts of long-vanished stars. When we observe the cosmos, it is the universe itself that is reflecting upon its own beauty and vastness through the human mind and spirit. Let your thoughts grow lighter now as we look toward what lies ahead. The future of exploration is unfolding with quiet determination and bold imagination. We are turning our attention to the frozen moons of our own solar system. Missions like Europa Clipper and JUICE will soon journey outward to study the hidden oceans beneath layers of ice, where unfamiliar forms of life may be quietly waiting in eternal darkness. Beyond that, we are designing new generations of telescopes, HABEX, Nautilus, capable of directly photographing Earth-like worlds and searching their atmospheres for the subtle signatures of life. Farther still is the dream known as Breakthrough Starshot, microscopic spacecraft propelled by light itself, racing toward Alpha Centauri at a fifth the speed of light. Humanity is learning, step by step, to shorten the vast distances written into the stars, so that one day our descendants may truly touch eternity. Night travelers, our bonfire is slowly fading now, leaving only glowing embers, like stars resting near the edge of the horizon. Tonight you have seen that the boundaries of space are not walls, but limits of time and perception. You have felt that even though we live on a faint blue dot, our consciousness can reach outward to ask the greatest questions ever known. The universe is like a vast book filled with pages still unwritten. We may be only a brief sentence at the beginning, but that sentence is the opening of all that follows. Now, Let thoughts of distant galaxies, of multiverses and vessels of light, dissolve gently into the mist of dreams. Space is your immense home, and Earth is the quiet, warm room holding you safely tonight. Everything moves within a great, patient rhythm, and so do you. Let your heartbeat fall into harmony with the slow music of the stars. Release the weight from your body. Let your eyelids grow heavy. Drift into peaceful sleep beneath the silken arc of the Milky Way. The universe began in a profound silence, and tonight it keeps watch over your rest with boundless calm. Sleep well, night travelers.